Okay, for this new unit, we're going to take a look at absolute values, absolute value functions, as well as reciprocal functions. So to start with, we're just going to take a look at what absolute values are and absolute value functions. So the absolute value of a number can be defined as a principal square root of the square of that number. Now, some people find this explanation a little confusing. I like to think of it just as if I have the number 6, it's positive 6. If I have negative 6, it's going to be positive 6. A good way to think of this is that it works as a distance. If I think of a distance, well, how far away from 0 is it? For 0, 6 is 6 units away. Negative 6 is also 6 units away, because we always think of distance in terms of positive. So it works the same way. The actual absolute value of any given number will never be a negative. It's always going to be the positive version of whatever that number is. So, anytime that I want to solve for an absolute value, and that's what these are, is just absolute value brackets, I'm going to say that the absolute value of 3 is 3. The absolute value of negative 3 is also positive 3. When I see something where it has a negative outside of the absolute value bracket, then this is going to give me the negative of the absolute value of 8, which is negative 8. Think of it as the same as multiplying whatever the solution is by negative 1. That means that if I take the negative absolute value of negative 8, well, the first step would be that the absolute value of negative 8 is positive 8, and then I would multiply it by a negative again. If I need to combine them, then I would solve the absolute values first because they're absolute value brackets. So thinking of our bed mass, we would do the brackets first. And this would give me 7 plus 7, which is just going to give me 14. If I'm following my bed mass rules, then I would need to solve what's inside the brackets before dealing with the brackets. So I would take that 1 minus 5 to get negative 4. And then when I take the absolute value of negative 4, it becomes positive 4. And for the last example, I would take the negative of the absolute value of negative square root of 81 is 9. And the absolute value of negative 9 is going to be positive 9, but I'm still going to multiply that by the negative 1. Now, you can always do this in your calculator. If you go to calculator and you click math, the right arrow wants to go numbers. The first option should be ABS, and that is where the absolute values are found on your calculators. Let's take a look at what this looks like for the functions. So we're going to start with the most basic one. The function where y, or f of x, is equal to the absolute value of x. The first thing we're going to do is we're going to graph two functions. One where g of x, or y, is equal to x, and one where h of x, or y, a second y, is equal to negative x. When I graph the first one, if y is equal to x, then 0 is equal to 0, negative 1 will be negative 1, negative 2, so on and so forth. Or 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7. Connect the dots, extend it on to infinity. When I take the negative version, 0 is 0, negative 1 would be positive 1, negative 2, positive 2, negative 3, positive 3, and so on and so forth. Or when x is positive, positive 1 would be negative 1, positive 2 would be negative 2, positive 3, negative 3, and so on and so forth. And once again, I'm going to connect the dots. I'm going to stretch it out onto infinity. And there's my two functions. One where y is equal to negative x, and one where y is equal to positive x. Now, if I'm going to graph out where y is equal to the absolute value of x, then when I take the absolute value of the number, I'm just going to solve for what the positive version of that number is. So -5 becomes +5, -4 is +4, -3 is +3, +2, +1, 0, 1, 2, 3, 4, and 5. And I can graph those points out. -5, +5, -4, +4, -3, +3, all the way to 0. And then when x is positive, they look the same. 1, 2, 3, 4, 5. And these would connect off and extend into infinity. Now, when it says, what are the similarities and differences? Well, I can see that these graphs look the same anytime that y is positive. I can see that they look different, or in this case it's just non-existent, when y is negative, which would make sense because the absolute value always has to be a positive. So when y is positive, or y is greater than or equal to 0, the graphs are the same. When y is negative, there is no absolute value graph. We can see that the graph for the absolute value contains two straight lines. One straight line here and a different one over here. We can see that they look similar where it says state the equation of the line in quadrant 1. Well, in quadrant 1, where I'm here, it looks identical to this line here. So in quadrant 1, it looks like y is equal to x. In quadrant 2, this one here looks identical to this one here. So in quadrant 2, we can say that y is equal to -x. So we can split the two straight lines into two pieces. And from there, we create what is called piecewise function. If there's anything that really carries forward with you, this should be the big one. We can say that it looks like the graph, or the graph in this case would be y is equal to the absolute value of x. And it's going to look like y is equal to x. If x is greater than or equal to 0, it's going to look like y is equal to -x if x is less than 0. All we're doing is we're splitting up using these brackets what my function is into the two pieces or the two straight lines that make up what it looks like. And we're setting the restrictions for, or the domains for, when it looks like those different things.